Namaste and a very, very good morning to all of you. I welcome you to my channel, The Outlier. In today's presentation, we will be looking at one sample t-test. What is one sample t-test? When do I use one sample t-test? One sample t-test is used when you want to compare the sample mean with the population mean. Now, to execute one sample t-test, I will be using a data set which is present in SPSS. This data set is called as breaks.sav. As you can see, this is the SPSS screen that I have. Let me click on the file menu. The second option here is open. I will choose the option data. SPSS expects me to go to the file where the data set is present. So let me just navigate the path here. I will go to C drive, program files, then click on IBM, SPSS, statistics, 26, and then I can choose the option samples, and then English. This is the folder which has all the data sets that you would need to try out some of the options. There are different data sets, as you can see here in front of your screen. The data set that I will be choosing is called as breaks.sav. I repeat, the data set that I will be choosing is called as breaks.sav. Let me choose the option open. As you can see here, this is the data set which has two variables. One is called as machine. The second one is called as breaks. Let me just go to the variable view. You can see here, when it comes to machine, the label is machine number. And when it comes to break, the label for this particular variable is disk break diameter, which is measured in millimeter. The first variable, break, is a nominal variable. Let me just give you a bit of a background about this data set. You have a popular automobile factory. They are manufacturing disc brakes. They're manufacturing disc brakes, and there are multiple machines here. As you can see here, there are 8 different machines here. The quality team randomly takes a sample of 16 from different machines, and they note down the disc break diameter in millimeter. So the first set of machines, which is machine 1, has a disc break diameter of 322.0003 millimeter. The second machine, but from the first set itself, has a disc break diameter of 322.0048. Like this, the quality team basically takes a sample of 16 machines from each set of machines, and they record the disc break diameter that it is producing. Now, the problem statement here is to check whether the disc break diameter produced by these machines is 322 millimeter or not. I repeat, the problem statement is to check whether the disc break diameter produced by these 8 sets of machines equals 322 millimeter or not. So 322 millimeter is a predefined value that we are checking for. How do I do this? To execute the one sample t-test, you can please go to the analyze menu. And here, the 5th option from the top is compare means. And within this option, you see a whole lot of options. I request you to check on the second option, which is one sample t-test. So please click on the option one sample t-test. Here, you can specify the test variable. I will choose the disc break diameter as the test variable. I have to enter the test value. Remember, we are checking whether the disc break diameter is 322 millimeter or not, and therefore I'm going to put a value of 322 millimeter. You can specify what is called as the population mean or any other predefined value here, depending upon what is the purpose of your analysis. Since I am checking whether the disc break diameter is 322 millimeter or not, I am choosing this option. Let me click on the first option, which is the tab, which is the options tab. By default, SPSS gives you the 95% confidence interval. I will click continue and then choose the option OK. As you can see here, There are, the sample size that I have is 128, and it is giving me summary statistics. On an average, the disc break diameter that is produced is 322.002. This is the disc break diameter that is produced. The standard deviation as well as the standard error is given. I can't make any decision based on the descriptive statistic itself. I will have to make a move on to what is called as one sample t-test. Now, as you can see here, the output of the one sample t-test is displayed here. The test value is 322 millimeter. The t-statistic value is shown as 2.1. The corresponding degrees of freedom is shown as 127, and the significance value or the p-value is also reported. If you look at the significance value turns out to be 0.038. I repeat, the significance value is 0.038. Please look at this number. It is 0.038. A simple thumb rule is compare this p-value with the level of significance. The level of significance here is 0.05. The question here is this p-value lesser than 0.05 or is this bigger than 0.05? We can clearly say that 0.03 is less than 0.05. And since the p-value is less than 0.05, I will go ahead and reject my null hypothesis and hence conclude that the average disc break diameter produced by the set of machines that we have taken is significantly different from the test value of 322. So this is the conclusion that I can draw, that I reject my null hypothesis. Why do I reject my null hypothesis? Because the p-value is small, and since the p-value is small, I will conclude by saying that on an average, the disc break diameter is significantly different from the test value of 322. So when you take a simple subtraction of 322 and 322.002, you will be getting the mean difference, which is of 0.002. What SPSS does is it also reports the 95% confidence interval for the mean difference. So this is the lower confidence interval, which is 0.0001, and the upper confidence interval is 0.003. So the mean difference value of 0.002 will lie within this interval. It will lie between the interval of 0.0001 and 0.0039. So this is how you can perform a one sample t-test, wherein you're checking whether the sample mean equals a population mean or any hypothesized value. With this, I come to the end of one part of the presentation. Let me just go back to the data set to show you the second part of analysis. The one sample t-test, if you remember, I have looked at the disc break diameter produced by all all 8 sets of machines. I looked at it collectively. Now, if you just take a step back and examine the problem, if you just contemplate what we're talking about, we are looking at the average disc break diameter produced by these machines and comparing it with a test value of 322. And we have come to the conclusion that it is different from 322. It could be that some of these machines are producing disc brakes whose average disc brake diameter is 322. But it could be that there is one set of machine which, because of the fact that it is old or because some of the components might have been worn out, this specific machine might be producing a disc brake diameter which is very different from 322. So since we have 8 different sets of machines, is it possible for me to do a t-test separately for each of these 8 machines, not collectively? What I did in the first part was collectively I checked whether the average disc brake diameter is 322. Now the problem statement would be to separately do one sample t-test for each of these 8 groups, which means I will be doing a t-test 8 times one for each set of machine. Even before I do this, let me just look at the EDA or the exploratory data analysis. To look at the EDA, please go to Analyze. Then you can come to Compare Means. Here, instead of choosing the second option of one sample t-test, I will choose the option which is called means. This is the first option. So let me choose the option means. It's asking me for the dependent variable and the independent list. The independent list will be the machine number and the dependent list will be the disk break diameter. You can take any scale variable under the dependent list. Please choose a categorical variable in the independent list. You can click on the Options tab. It shows you a wide variety of statistics. You might not need everything. I'm specifically interested in the mean value. I can choose Continue and then click on OK. As you can see here, for each of the 8 sets of machines, it is giving me the sample size, which means that there are 16 sets of machines corresponding to machine number 1. There are 16 sets, there are 16 machines corresponding to the set 2, so on and so forth. And for each of the machine set, it is showing me what is the average disk break diameter. For example, for the first set of machines, the average disk break diameter is 321.99 millimeter. For the second one, the average disk break diameter is 322.01. And for the third one, the average disk break diameter is 321, so on and so forth. Now, many times when you want to present this to the top management, presenting tables, sometimes when people look at tables, it becomes a bit boring. People may not comprehend each of the numbers. So a better way of showing the same thing would be through graphs. Let us just try to show the same thing through graphs. To show the same thing through graphs, let me click on the Graphs menu. The second option here is Graph Board Template Chooser. I repeat, the second option here is Graph Board Template Chooser. Please click on this option, Graph Board Template Chooser. I've got 2 variables. Let me choose both of these variables. I can either go with a bar chart or a box plot. Let me choose a bar chart. I'll click on the Detailed tab here. Please click on the Detailed tab here. It is giving me the preview of a bar chart. Now, the default statistic is total. It will give me the total disk break diameter. I'm not interested in the total. I'm interested in the average disk break diameter. And I want it to color. I want it to give different colors for different machine numbers. So please choose color by different machine number. And then you can choose the option OK. You can see here, SPSS quickly comes up with a bar chart. In the x-axis, you have 8 different groups of machines, and the y-axis, it has shown the average disk break diameter, right? Now you can see here, the second machine is on the higher side, which means that the second machine produces a disk break diameter, which is looks like, my first impression is that its disk break diameter might be different from 322 millimeter. The same way, when you look at machine number 5, 6, and 7, this again looks like there is some kind of a difference that you can expect for machine number 5, 6, and 7. Are these differences real? Are these differences not real? To examine this, what we can do is we can go ahead and we can do one sample t-test for each of these 8 sets separately. But even before I jump to one sample t-test and show you one sample t-test for 8 sets of machines, let me show you another interesting option within graphs. I am going to click on graphs and choose Graph Board Template Chooser. It shows me the different graphs that are applicable for my data set. I can go to detailed. You can see this option here, visualization type. Many times along with the average, if you also want to study the variation, what I would suggest is please scroll down. a box plot is an excellent option using which you can study the variation in addition to the average performance. Again, I will request for 8 different box plots for each of the machines, and I want SPSS to come up with a different color for each of these 8 machines. Once I specify machine number for color, I can click on the option OK. You can see here, this is very, very interesting. And for 8 different sets of machines, you see 8 different box plots. And you can see the thick line here represents the median. So you can look at what is the average disc break diameter for each of these 8 sets. My first impression when I look at the box plot is machine 1 looks okay because the average disc break diameter is around 322. I do not expect much of a problem for machine 3. For machine 2, yes, there could be a problem. The same goes for machine 5. There could be, it is slightly on the higher side. Machine 6, slightly on the higher side. Machine 7 could be problematic as well. So my impression, my first impression when I look at the box plot is machine 2 and machine 7, machine number 2 and machine number 7 may have an average disc break diameter which is different from the test value of 322. The big question before us is, are these differences real or is it by chance? Now to do this, I'll have to play an interesting trick here. And let me just show you this trick. I want 8 different sets of machines. I want 8 different sets of t-tests for each of these machines. So what I will be doing is, I will go to the data menu. In the data menu, the last but second option here is what is called as a split file. In the data menu, the last option is weigh cases. Don't choose this. Please don't choose select cases. What I request you to do is please choose split file. Let me just click on OK. Now, the moment you click on OK, what happens is at the bottom right-hand side corner, you usually see a message. I have not executed this option and therefore it is not getting highlighted here. This is the split file menu. I can choose the option organize output by groups. I will choose machine number in the box corresponding to groups based on. You can choose any categorical variable. Under this option of groups based on, I will choose the option machine number and then click on OK. It is taking me back to the output. I don't want to go back to the output. I want to look at the data window. So this is the data window. And if you have done this properly, you should be able to see a message at the right-hand side bottom corner, which says split by machine. I repeat, it says split by machine. If you have not done this step properly, you will not see any machine. Now, what I've done is basically, I have split this entire file into 8 chunks, 1 chunk corresponding to each machine. Now, when I execute a t-test, the same t-test will be executed 8 times. It is like in R or Python, if you're doing the same thing, you would be putting a for loop, and each of these for loop will be executed 8 times. So I'm executing the t-test 8 times, 1 corresponding to each set of machine. Let me click on the analyze menu and then go to compare means. This is the 5th option from the top. I'm conducting the 1 sample t-test. Let me choose 1 sample t-test. So I'm not going to make any changes here. Let me go ahead and choose the option OK. Right. Very interestingly, you can look at the tree map here. So this is where my t-test begins. You can see here, now this t-test is applicable only for machine number 1. When you look at the heading here, it says machine number equals 1. So this is not for the entire data set. This is only applicable for the first set of machines. On an average, the disc break diameter is 321.99. And when you look at the p-value, the p-value is 0.602. Very, very important. the p-value is bigger than 0.05, which means that the average disc break diameter produced by the first set of machines is in line with my expectation. It is very close to my test value of 322. So there is no problem as far as the first set of machines is concerned. Its average disc break diameter is very close to 322. Let me look at machine number 2 and look at the t-test corresponding to machine number 2. Please look at this. This is machine number 2. And when I look at the significance value here, it is 0.000. So when you look at machine number 2, I'd like to draw your attention here. This is very, very important. The average disc break diameter produced by the second set of machines is significantly different from the test value of 322. And therefore, I'll have to reject my null hypothesis and conclude accordingly that the average disc break diameter is not 322 millimeter when it comes to machine 2. Right? This is very, very important. Let me look at machine 3 here. Now for machine 2, this looks satisfactory. The p-value is greater than 0.05. Since it is greater than 0.05, you can conclude that there is no problem. The average disc break diameter is very close to 322. Let me look at machine number 4. Machine number 4, the p-value is 0.02, which is less than 0.05. And therefore, you conclude that the average disc break diameter for machine 4 is significantly different from 322 millimeters. I will now make a move on to machine number 5. Machine number 5, when you compare, when you look at the p-value, it is 0.08, which is greater than 0.05. And since it is greater than 0.05, the average disc break diameter produced by machine 5 is close to 322 millimeter. Look at machine 6, the p-value is greater. Look at machine 7, the p-value is smaller than 0.05, and therefore you will conclude by saying that the average disc break diameter produced by machine 7 is not equal to 322. And the last machine that I have is machine 5. Look at the average disc break diameter. It is 0.107, greater than 0.05. And since this is greater than 0.05, we can conclude by saying that the average disc break diameter for machine number 8 is equal to 322. To summarize, it looks like machine number 2, machine number 4, and machine number 7 are producing disc break diameters which are very, very different from 322. If you look at the box plot, this is what comes through, that for machine number 2, machine number 4, and machine number 7, the average disc break diameter for the sample is different from 322. So with this, I have come to the end of today's presentation. To summarize the discussion that we have had, in this discussion, we have seen one sample t-test, how to perform one sample t-test in SPSS. We looked at two important graphs, namely bar chart. We also looked at box plot. We looked at the descriptives, and we also did some data munging. We looked at data and split file as to how you can divide the data and run a t-test separately for each of the 8 groups. I hope you have liked this presentation. I request you to subscribe to my channel and like this particular video. I will see you in my next video. Thank you very much.